group projects. In this video, we are going to explain about the project entitled as Fire and Smoke Detection based on Improved YOLO V5. So before getting into the video, let me give you the brief description about the project. The project aims to develop a real-time vision-based system for early fire detection using an enhanced YOLOV11 deep learning model. The improved architecture focuses on accurately identifying fire and smoke even in complex environments with varying light and backgrounds. By leveraging advanced feature extraction and faster interference, the system improves detection accuracy and reduces false alarms. This approach is suitable for real-time surveillance and safety monitoring applications. Coming to the abstract, this abstract explains the need for an effective fire and smoke detection system to prevent disasters at an early stage, especially in environments such as industries, homes, and forests. It highlights the limitations of traditional sensor-based methods, which may respond slowly and cover only limited areas. To overcome these issues, the work adopts a vision-based approach using deep learning, specifically an improved YOLO V5 model. The improved model enhances feature extraction to better detect small and low visibility elements like smoke, resulting in higher accuracy and faster real-time detection. Overall, the proposed system provides a more reliable and efficient early warning solution compared to conventional fire detection methods. Coming to the existing system, the existing fire and smoke detection system mainly use physical sensors such as smoke, heat, and flame detectors to identify fire incidents. Although the systems are commonly developed but often suffers from slow response time, limited coverage, and are easily affected by environmental factors like dust, humidity, and airflow. To overcome these issues, vision-based systems using deep learning models such as CNNs and earlier YOLO versions have been developed to detect fire and smoke from images and videos. However, these models still face challenges such as frequent false alarms, difficulty in detecting small or transparent smoke, and reduces performance in complex background and changing light conditions, which limits their reliability in real-world scenarios. Coming to the proposed system or base paper work, the proposed system is designed to detect fire and smoke accurately and effectively by using an improved YOLO versions for YOLO V11 deep learning model. The improvements focuses on enhancing feature fusion, optimizing anchored settings, and incorporating attenuation mechanisms so that the model can better capture detailed and suitable visual characteristics of fire and smoke. This allows the system to detect small, low contrast smoke regions and flames more reliably, even in changing conditions such as low light, fog, or complex backgrounds. As a result, the system achieves higher detection accuracy, fewer false alarms, and faster real-time performance, making it well suitable for continuous surveillance and early fire warning applications. Coming to the dataset, the dataset consists of a large, well-annotated collections of fire and smoke images designed for training and evaluating modern object detection models. It contains overall 11,000 labeled images with bounding boxes annotated in YOLO format for two classes, fire and smoke. The image represents diverse real-world scenarios, including indoor and outdoor environments, different weather conditions, varying light, and complex backgrounds, which helps the model to learn robust and generalizable features. The dataset is divided into training, validation, and testing subsets. Typically follows an 80-10-10 split to ensure reliable performance evaluation. Due to its size, diversity, and standardized annotations, the dataset is well suited for training model YOLO architectures and significantly reduces outfitting compared to smaller datasets. Coming to the novelty or extension or enhancement or improvement. The extension of this work includes applying YOLOV11X, the largest and the most advanced variant of YOLOV11 family, to improve the detection of abnormalities in images by leveraging its deeper architecture and enhanced feature extraction capabilities. This extension enables more accurate identification of suitable and complex visual patterns compared to lighter model variants. In addition, the Flask framework is used to develop a user-friendly web interface that allows users to upload images or videos frames and obtain real-time predictions from the trained models. This integration makes the system more accessible and practical for real-world deployment, enabling easy interaction and visualization of detection results. Coming to the flow of the work, first, dataset preparation. Fire and smoke images are collected from diverse sources and bounding boxes annotation are created in YOLO format to localize fire and smoke regions accurately. Next, pre-processing. YOLO specific pre-processing is applied including image resizing and normalization. A data.yaml file is created to define dataset paths and class names, and parallel datasets are maintained for detection and classification. Next, model training. Existing YOLO models such as YOLO V5, YOLO V8, and YOLO V9, V10, and V11 are trained to establish baseline fire and smoke detection. Coming to the proposed models, YOLO V11 DH3 model is trained with architectural improvements to enhance feature extraction and detection accuracy for fire and smoke. And as an extension, YOLO V11X, the latest YOLO V11 variant, is trained to further improve detection robustness and performance. Coming to the evaluation, all trained models are evaluated using the metrics such as MAP, precision, and recall, and their performance is compared to identify the best detection model. And next we have interface and deployment. The trained model is deployed using Flask framework. The trained model is deployed using Flask web application where users can upload images and receive output images with bounding boxes predicting fire or smoke classes and confidence score. The algorithms used in the project are YOLO V5, YOLO V8, YOLO V9, YOLO V10, YOLO V11S, YOLO V11 DH3, and as an extension we have applied YOLO V11X. Coming to the requirements, we have both hardware requirements and software requirements. Hardware requirements consisting of operating systems, Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements consisting of application framework is Anaconda, primary language is Python, front-end framework is Flask, backend is Jupyter Notebook, database is SQLite 3, technologies which we use to build the front-end are HTML, CSS, JavaScript and Bootstrap 4. To execute the project, first we need to open the code folder which contains the project source code files. This folder is a complete package of your project's code base containing everything needed to develop, test, and deploy your application or model. Static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. Templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute the code in individual cells, making it a popular choice for data science. Signup.db file. This file is a database file used to store the user information. Now, coming to the execution of the project, firstly, copy the path of the code folder from the address bar of the file explorer. Then, open Anaconda prompt. by using the command cd followed by a space and then paste the copied path. This command is used to change the current directory to the code folder's path. Now, compile the app.py file using the command python space app.py in Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address with the port number of 5000. Copy the link provided by the framework and paste it into any web browser. I prefer Chrome. The home page of the project should now be displayed in the browser. This is a front end using Flask framework. In this page, we have home button and register button. Now, click on register button so that the logon HTML will be opened. Here, we need to give the details and create an account for user authentication like username, full name, mail ID, mobile number, and a strong password. Then click on register so that all the given details are stored in signup.db and the login.html will be opened, where we need to access the application by username and a password. Then click on sign in so that the prediction page has been displayed. In this page, we have fire and smoke detection button, data visualization button, explore notebook button, and logout button. Firstly, click on fire and smoke detection button so that the uploadation your image path will be opened, where you need to upload the image from the code folder, choose samples and choose any one image. Then click on detect fire and smoke so that the input image is pre-processed and the output will be displayed as the detection results. Total we have 4 detections. Fire detections are 2 and smoke detections are 2. This is a detected image where you can see the boundary boxes like fire is 2 and smoke is 2. Total we have 4 detections. And we also have the detection details like smoke, detection 1, the confidence score and the class. We also have the fire, detection of 2 and detection 3 is of smoke and detection 4 is of fire. Here we have upload other image button and view graphs button. When you click on upload another image button so that the uploadation of the image will be opened where you can upload the new image and again detect the detections. Now click on data visualization button so that the graphical representations of the project will be opened. So first we have YOLO precision graph. The precision graph highlights how accurately each model predicts fire and smoke by measuring the proportion of correct detections among all predicted detections. The baseline YOLO models maintain high precision, indicating fewer false alarms. The proposed YOLO V11 DH3 has relatively low precision, suggesting an increased number of false positives. The YOLO V11 extinction model improves precision significantly, striking a better balance between detection true fire or smoke events and reducing incorrect detections, making it more reliable for real-world deployment. Next, we have YOLO recall graph. The recall graph illustrates each model's ability to correctly detect fire and smoke instants without missing them. Most baseline models achieve very high recall values, meaning they successfully identify most true fire and smoke cases. The proposed YOLO V11 DH3 shows a noticeable drop in recall, indicating that some instants may not be detected. However, the YOLO V11X extinction model restores the high recall performance, proving its effectiveness in minimizing missed detections, which is critical for safety-oriented applications like fire detection. And next, we have YOLO MAP graph. The MAP graph compares the overall detection accuracy of different YOLO models by considering both classification and localization performance. From the graphs YOLO V5 through YOLO V11, S shows consistently high MAP values, indicating Strong baseline performance. The proposed YOLO V11 DH3 model shows a comparatively low MAP, suggesting room for improvement in overall detection accuracy. In contrast, the extension model YOLO V11X achieves one of the highest MAP scores, demonstrating superior detection capability and better generalization across fire and smoke scenarios. And then click on Logout. So finally, this project successfully demonstrates an effective fire and smoke detection system using an improved YOLO V11 architecture. The enhanced model achieves higher accuracy, better localization, and reliable real-time performance even in complex environments. Comparative analysis with multiple YOLO versions confirms the superiority of the improved and extended YOLO V11 models. Overall, the proposed approach provides a robust and practical solutions for early fire detection and safety monitoring applications. So this is all about your project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.